Today we're going to do a single stock analysis where we look at Chipotle versus some of the inflationary pressures they might be facing from the lens of US CPI prices for common Mexican food ingredients. To make this challenge a little bit more realistic and difficult, what we'll do is we'll have Sphinx actually go into a raw Snowflake database where we've loaded a large amount of macroeconomic information and have it discover through exploration where the right data is, what the right features to use are, and then construct us a model to allow us to understand if Chipotle stock price can be, at least to some degree, predicted through CPI prices of underlying commodities. So let's get started with this prompt. Tossing it into the model, we get first Sphinx obviously having to go into, in this case, Yahoo Finance, a pretty standard free finance API to go get the prices. That's fine, it'll find the prices. Now it will go into our Snowflake database. So of course, it has some configuration from our end on how to connect to Snowflake of using a certain token based off. Of course, when it's in your system, it will respect your RBAC, your token based off however you want Sphinx to use your databases. And it will start by effectively acting the way that you would as a data scientist, poking through your tables, looking for the right information. It sees there's a bunch of tables, and here it can now move to a semantic type of approach where it will say, okay, there's some BLS data, that's probably where there's inflation. Let's see if we can find something that contains all these various ingredients. But of course, its columns are not fully correct, so it does need to go inspect what those columns are. This really is like a fundamental principle for us. We don't really want to get SQL read in one shot. We want to run the code and make sure it's logically consistent. Even if it runs, that's not that important compared to the results being logical and good features to be used. It'll create a list of various things that it thinks could be used as features, tortillas, beans, etc. And it will go and semantically hunt for these in now the correct place within our database, since it's been able to find that already. And it's identified a bunch of candidate time series, which of course will then map to tables that it can go pull in. And now we can actually start pulling in that data. So we'll write some more SQL logic, this time, of course, a much more aggressive pull to go pull in the full history for those time series. Seems like some of them go back all the way to 1980. And we found that data, and we should now start to be able to clean it up, join it together, and make the regression. Now we will actually have to pull a little bit more. It seems like we actually only pulled part of the data. And of course, Sphinx will realize this, that there's a partial pull, and go and figure out the rest of it. So let's see what it's able to accomplish next. Great. And of course, we can read the summary on the right to see that we have gotten the CPI now fully pulled. It'll aggregate the stock price to the monthly last close of the month, which I think is quite reasonable to align with when the CPI is released. And it will deal with some of the annoying data manipulation work that's to happen here, data sanitization work, pivoting the table, dealing with nulls, deduplication, etc. Having done that, we can now get to the hardest part here, probably, which is joining these two data sets, obviously coming from different sources with different datetime formats. And this join, of course, is empty at first. Sphinx will not obviously stop there. It'll figure out what's wrong with it. It's going to go inspect some of these values, and it seems like there's some datetime formatting issue where, okay, yeah, first day of the month versus last day of the month for the aggregation. It'll go and fix that to period end. Obviously, period end makes sense here given that the stock price is from period end and the CPI is for the full period, so it's a little bit irrelevant which option we pick there. So there's, of course, continuing merge issues given that they're different tables, different sources, and Sphinx will then solve these one by one. So now we've fixed some kind of column naming issue. Having done that, we do actually now have a join that contains some data that we can actually pair together. So, okay, good. So now we have the data. Let's fit the rolling forward regression model. And I think this is a good baseline, just a linear regression fit in a rolling forward manner to make sure that we have some kind of temporal holdout set that is not going to allow us to leak information. Sphinx will go and do that for us. It'll write out all the code. It seems to be using stats models here, so we'll hopefully get a lot of interesting statistics that we can analyze for the model fit. Seems like there's some issue with the shape of the data. Again, like a pretty common issue in setting up these regressions. Sphinx will, of course, figure out this problem, rewrite the code. And of course, store some other features. And there we go. We now have a fitted model that seems actually quite good. It reflects the fact that maybe these inflationary pressures are quite important for Chipotle, and they do kind of give some sense. Obviously, there's a little bit of lag structure here that we can investigate in further questions to the model of like maybe put it into a growth space instead of a level space. Obviously, a reasonable thing to do here. But we can actually find that this model has been successfully built. We've done the data discovery, effectively the work of plumbing the database, finding the right stuff, pulling that all in, dealing with the formatting, joining it all together, and then, of course, building out the model. Takes about 5 minutes of work by the agent, and of that time, a couple seconds of actual typing and introspection from the human quant who is running this process.